Good day, I am Borja from Bsit 2103, and for today's video, I am going to answer the activities in Chapter 5. The first activity is entitled MAC and LLC Sublayers. Instructions. Descriptions of the MAC and LLC sublayers are provided in the table. Click the MAC or LLC fields to match the descriptions to the correct sublayer. The first one is controls the network interface card through software drivers. I think this is LLC. Work with the upper layer to add application information for delivery of data to higher level protocols. I think this is LLC also. Works with hardware to support bandwidth requirements and checks errors in the bits send and receive. I think this is MAC. Controls access to the media through signaling and physical media standards requirements. I think this is also MAC. Supports Ethernet technology by using CSMA or CD or CSM or CA. I think this is I also MAC. Remains relatively independent of physical equipment. I think this is LLC. So let's check if my answers are all correct. All of them are correct, so I will discuss the difference between MAC and LLC. LLC or Logical Link Control and MAC or Media Access Control sublayers. As for LLC, this sublayer acts a link between the upper layer or network layer and the bottom layer or the physical layer. It is responsible for identifying network layer protocols. Put another way, when a frame coming from a remote host or source reaches a computer in a logical network or destination, as you know, the frame is first generated at the source machine starting from the application layer down to the physical layer. It is slipped off of the header and trailer of the data link layer, which you will when it is passed on the network layer. Now LLC or Logical Link Control sublayer has also another function, which is providing flow control and error detection. I know that you are wondering how come flow control to take place at the data link layer since it is already done at the transport layer. But do not worry, everything will be clear because every single concept is adequately explained. MAC or Media Access Control sublayer. In addition to LLC Logical Link Control, MAC sublayer has equally significant functions. It provides data link layer addressing and puts frames on the media to take the journey across the network towards the destination. Addressing in the data link layer is providing the frame generated at the sending machine with a source address and destination address called MAC address so that the frame is destined to its correct receiving machine. More precisely, as you saw, the MAC address or hardware address is unique identifier which consists of 48 bits in hexadecimal. This address is burned on any network device, which means that it is unchangeable. The purpose of the LLC header is to provide a hole in the ceiling of the data linker by specifying into which memory buffer the adapter places the data frame. The LLC header allows the upper layers to know where to find the data. This is the second activity in chapter 5.1.6 entitled Ethernet Frame Fields. Instructions: drag the 802.3 Ethernet frame field name to its description. The first one, use pad to increase this frame field to at least 64 bytes. I think this is 802.2 header and data. Describe which higher layer protocol has been used. I think this is type. The frame originating NIC or interface MAC address. I think this is source address. Assist a host determining if the frame received is addressed to it. I think this is destination address. Notifies destination to get ready for a new frame. I think this is preamble. Synchronizes sending and receiving devices for frame delivery. I think this is start of frame delimiter. And the last one, this detects errors in an Ethernet frame. I think this is frame check sequence. And we will see if my answer are all correct. Let's check. All of them are correct, so I will discuss each of them. The 802.2 Logical Link Control or LLC header. The purpose of the LLC header is to provide a hole in the ceiling of the data link layer by specifying into which memory buffer the adapter places the data frame. The LLC header allows the upper layers to know where to find the data. A frame check sequence or FCS refers to an error detecting code added to a frame in a communications protocol. Frames are used to send payload data from a source to destination. A preamble is a signal used in network communications to synchronize transmission timing between two or more systems. In general, preamble is synonym for introduction. A network address is any logical or physical address that uniquely distinguishes a network node or device over a computer or telecommunication network. It is a numeric or symbolic number or address that is assigned to any device that seeks access to or is part of a network. Types of network. Computer networks fall into three classes regarding the size, distance, and the structure, namely LAN or Local Area Network, MAN, Metropolitan Area Network, and WAN or Wide Area Network. The start frame delimiter is a signal byte 10101011, which is a frame flag indicating the start of a frame. The MAC address used in 802.3 are always 48 bits long, although older version of Ethernet use 16 bits. A subnet must specify which part of an address is the network part and which part addresses the specific host. A packet with the destination address that is not on the same network as the source address will be forwarded or routed to the appropriate network. This is the last activity in chapter 5, which is 5.2.2.4, entitled Frame Forwarding Methods. Instructions. Descriptions of switch frame forwarding methods are provided in the table. Click in the store and forward or cut through fields to match the methods to the descriptions. First, buffers frames until the full frame has been received by the switch. I think this is store and forward. Checks the frame for errors between releasing it out of its switch ports. Is if the full frame was not received, the switch discard it. I think this is stored and forward also. No error checking on frames is performed by the switch before releasing the frame out of its parts. I think this is cut through. Algorithm method to use to conserve bandwidth on your network. I think this is start and forward. The destination network interface card or NIC discards any incomplete frames using this frame forwarding method. I think this is cut through. The faster switch method but may produce more errors in data integrity, therefore more bandwidth may be consumed. I think this is cut through, and let's check if my answer are all correct. All of them are correct, so I will discuss the difference between the two of them. Store and forward switching. In store and forward switching, switch copies each complete Ethernet frame into the switch memory and computer. A cyclic redundancy check or CRC for errors. If a cyclic redundancy check or CRC error is found, the Ethernet frame is dropped, and if there is no cyclic redundancy check error, the switch forwards the Ethernet frame to the destination device. Store and forward switching can cause delay in switching since CRC is calculated for each Ethernet frame. Cut-through switching. In cut-through switching, the switch copies into its memory only the destination MAC address or first 6 bytes of the frame before making a switch decision. A switch operating in cut-through switching mode reduces delay because the switch starts to forward the Ethernet frame as soon as it reaches the destination MAC address and determines the outgoing switch port. Problems related with cut-through switching is that the switch may forward bad frames. And that's all for today. Thank you for watching.